Hi students, in the last lecture we have learned conservation of mechanical energy. Let us now solve questions basing on that. Say first question. A block of mass 5 kg is suspended from the end of a vertical spring which is stretched by 10 centimeter under the load of the block. The block is given a sharp impulse from below so that it acquires an upward speed of 2 meter per second. How high will it rise? This is now question given, and I have taken this question from H.C. Verma and see how to start the problem. Mass is 5 kg, elongation 10, and given speed 2 meter per second. Right, first of all, write down the given data. Mass given 5 kg, elongation take it as x naught, 10 centimeter, or you can say 0.1 meter, and velocity given that is 2 meter per second. Okay, and you can see a diagram for this. Suppose this is unstretched position, unstretched position. Given elongation is now 10. That means initially block was at this position, right? This was the initial position of block, and elongation we have taken it is x naught, which is at 10. Now we are giving a velocity 2 meter per second. It is upwards velocity b. Now it is rising, right? We have to calculate how much height block rises. Let us take block is rising by a height h. Block is rising by a height h. Let us take raised up to here. Rising from where means it is from here, right? Initial position, that is now height raised. So take it as h, which we have to calculate. Okay. So here we are going to use law of conservation of mechanical energy. Okay. And see here what we are doing. We are taking the spring, block, and earth as a system. Okay. That means spring force, internal force, gravitational force, also internal force. And if you want to apply that, first verify conditions. Work done by external force is equal to delta K plus delta U. So here spring force and gravitational force both are internal forces which are conservative. Okay. And you can see by external force. Here external force is only one force, that is force by sealing on the spring. And this point has no displacement. That means by that force no work is done. Therefore, this is equal to 0. That's why delta K plus delta U equal to 0. Okay. That means we can write K1 plus U1 is equal to K2 plus U2. Okay. Right now, see carefully. So whenever we want to take gravitational potential energy, first we have to consider a reference level, and which is a complete our choice. I'm taking now this initial level as reference level. I'm taking this as now reference level. So according to this assumption, Initially, block was having no gravitational potential energy, only kinetic energy and spring potential energy. Okay, so kinetic energy of m v square, spring potential energy of kx naught square. That is equal to, finally, when it reaches maximum height, velocity will be zero, right? Maximum height. Therefore, no kinetic energy, zero. Now coming to spring potential energy. Now see carefully here. X naught is elongation. H is a height raised. According to diagram, H is greater than X naught. Okay. So this extra part, H minus X naught, is a compression. Okay. So spring potential energy will be half K H minus X naught. Square of that, right? Remember here, this H value may be greater than X naught or maybe less than X naught. We can take anything because here we are taking H minus X naught square. So whether we take H minus X naught or X naught minus H, both are same only. Okay. So this is a completely our choice. So according to this diagram, H is now more. Next, coming to gravitational potential energy, it has raised by distance that is now h from the reference level, and above reference level means gravitational potential energy is positive. So I'm writing here positive value mgh. Okay, and we have to take one more condition. Initially block was in equilibrium, it was in equilibrium. So what I can write here, mg equal to kx naught. Okay, because initial block was in equilibrium. Now expand this, half k h square plus half k x naught square minus 2k, sorry, 2 gets cancelled, anyhow 2 gets cancelled, k x naught h plus mgh. Okay, so I can cancel both sides, half k x naught square. I can cancel both sides, half k x naught square, that's cancelled. Next, we can see one more, kx naught equal to mg in the place of kx naught mg. So mgh, these two are now cancelled. And this is already cancelled. Remaining is now half mv square, that is equal to half k h square. Okay. So in this you are knowing mass is given, V given, k value. We have to get k value from equation 1. Okay. From equation 1, we can say mass is known, G value given 10, X not given. So we can find K value. That we have to substitute here, K value. Then we can get the answer, right? 2 gets cancelled. Okay. 2 gets cancelled. H equal to root of M by K into V, right? Or in the place of M by K. See what I can write? In the place of M by K, I can write M by K, I can write it is X naught by G, right? That is from 1 into V. X naught given, right? X naught value given how much? 10 centimeter. Substitute here. Root of 10 means 0.1 meter. G value 10 into V. Right? V value how much? 2. So V value 2. That means how much we get? This is 1 by 100. That means 1 by 10. 1 by 10 into 2. Right? That is meters. That means if you are converting into centimeter, this becomes how much? 2 cancel 5 times here, 1 by 5 centimeter. That is now 20 centimeter. See calculation once. 0.1 by 10. 1 by 100, that becomes 10, right? So 2 by 10 meter means 1 by 5 meter. Converting into centimeter, 5 here 20 times. It is 20 centimeter. Like this, we can use conservation of mechanical energy. Okay. See next one. A uniform chain of mass m and length l overhangs a table with its two-third part on the table. Two-third part on the table. Find the work to be done by a person to put the hanging part back on the table. So place that hanging part back on the table. How much work is done? Right. See carefully. Given two-third part on table. Suppose this is now table. We have two-third part on the table. So one-third part is a hanging. This is now 2 by 3L. Okay. One-third is hanging. So we have to put this hanging part also on the table. So how much work is done? That means we have to calculate work done by external force, right? Getting it. And we are knowing that work done by external force is equal to delta K plus delta U, right? This is what we have learned in earlier class. By external force work equal to delta K plus delta U. Assumption is that all internal forces are conservative. Let us take here chain and earth as a system. Then gravity becomes internal force, right? Okay. And initially chain was at rest. After placing this part on the table, then also chain will be at rest. That means in both cases, there is no kinetic energy. Therefore, delta K is 0. Remaining is only delta U. That means by external force work equal to delta U. Therefore, we are going to focus what is gravitational potential energy. And if you want to calculate that, so first we have to take reference level, which is completely our choice. So I'm taking now this table as reference level. Taken table as reference level. So this is now reference level. Now chain is below the reference level. Therefore, for this hanging part, gravitational potential energy will be negative. Okay. And the part which is on the table, potential energy will be 0. Right. Now for this hanging part, see how to calculate potential energy. We are knowing that for a point mass, gravitational potential energy equal to mgh per point mass. Okay. But this is not a point mass. So in such a case, we have to take integration. Okay. See how I'm taking here. Let us take from here at a distance y, element of length dy. Okay. Dy means it is very small. So it is a point mass. Okay. For that point mass, potential energy will be, see how much? Its mass will be m by L into dy. Its mass. Okay. M G H equal to, we have taken at a depth y, right? It is y. Okay. And we have taken this is below reference level. So it is negative. So I'm taking a negative side. Okay. Like this, we have to consider all elements from y equal to 0 to y equal to L by 3. So integrate. So this gives us initial potential energy. Okay. L equal to, sorry, that is y equal to y equal to taking limits y equal to 0 to up to L by 3. Okay. See what we get? Taking minus outside mg by L taking outside y dy. So y square by 2. How much? Y square by 2. I'm taking 2 outside. We'll take limits also. L square by 9, right? And 1 L gets cancelled. This is now minus mgl by 18. Okay. That is the gravitational potential edge of the chain. Okay. When it was hanging, right? Now we're bringing this one onto the table. That means now entire chain is on the table. Therefore, potential energy will be 0. So here what is delta U? Delta U equal to, because this is nothing but work done by external force. That is equal to delta U, final value minus initial value, minus mgl by 80. Okay. So answer equal to mgl by 18. Okay. Students, actually here we have taken integration, but since chain is uniform, directly we can take center of mass. Okay. That means I will write here. Since the chain is uniform, okay, directly can take center of mass. That is potential energy equal to mass is m by 3. Mass of hanging part mg. Distance equal to taking center of mass. That is length is L by 3. Midpoint of that L by 6. Right. It is L by 6. Since it is now below reference level, we should take negative. That is what we have taken here, okay? But remember, this is only when chain is uniform. Otherwise, we have to follow same, take the integration, okay? Like this, we can take potential energy for a body, which is not a point mass, right? See next one. Right, first see the question, what is given. When a body is projected up vertically at a point P, vertically, at a point P in its path, ratio of potential to kinetic energies is 3 is to 5. If the same body were to be projected with 2 times the initial velocity, what is it? 2 times the initial velocity, the ratio of potential to kinetic energies at the same point is. Okay. See how to use here also conservation of mechanical energy. Given 3 is to 5. Velocity is now doubled, right? Velocity is now doubled. Velocity is now doubled. First, write down here potential to kinetic energy, right? Potential to kinetic ratio given how much? 3 is to 5. Okay. So when we project a body vertically upwards, at the time of projection, kinetic energy of m is. If you consider this ground as reference level, total energy will be only kinetic. Okay. Only kinetic. So here we are taking now earth particle system. Then gravity becomes internal force. So at a height, given ratio 3 is to 5. Okay. 3 is to 5. That means let us a total value. Total value is sum x. Okay. Then out of x, you can see here 3 is to 5 means totally 8 parts. Out of 8 parts, 3 parts are potential energy. Okay. 3 parts are potential energy. So out of this, what I can say here, potential energy equal to, this is now, or I can say potential energy 3 by 8 x, kinetic energy 5 by 8 x. Okay. Now here what happens is velocity doubled. Velocity doubled means its kinetic energy becomes 4 times. That means in the place of x, I have to write 4x. 4x, that means 4x. But remember, at the same height, potential energy will be same. Okay, no change in that. I am repeating. Since we are taking same height, potential energy means what we have to write. It is mgh. No change in mass, no change in g, no change in height. So no change in potential energy, but a kinetic energy will change. So this becomes now 4x. Okay, the initial value becomes 4x. But potential energy remains 3 by 8 of x. But coming to kinetic, see what happens. Otherwise, I can take like this. Otherwise, what I can say here, becoming 4 times that 4 times means total value becomes how much? Total number of parts will be, here it is 3 is to 5 means 8 parts. This is now equal to those 8 parts, right? 8 parts. This becomes now 32 parts. Okay. 32 equal parts. 32 equal parts. Out of that, 3 parts will be by potential energy. 3 parts. Remaining will be 29. That means directly ratio will be 3 by 29. See carefully. Total energy has become 4 times. 4 times. So here we have taken 3 plus 5, 8. Okay, 8 equal parts. Now it becomes, it is into 4, 32. 32 equal parts. Out of 32 equal parts, 3 parts are taken by potential energy. Remaining 29 parts are taken by kinetic energy. So answer is 3 is to 29. Okay. So the answer is now 3 is to 29. Okay. Right. See next one. Uniform chain of length L is placed on a smooth table of height h with a length L hanging from the edge of the table. Chain begins to slide down the table. When the end of the chain is about to leave the edge of the table, its velocity is, right. We have to find velocity. Total length is a capital L and a hanging length is small l, right? See how we are going to solve it. So total length is L. Out of the total length L, small l is now hanging, right? Earlier we have taken logic is that when chain is now slipping, okay, it is now losing gravitational potential energy. If this is now Earth, okay, now take what is now reference level. or I can take like this. Work done by external force is equal to delta K plus delta U. So take now this is chain and earth as a system. So gravity becomes now internal force. And you can see force by the table on the chain. It is upwards, vertically up. So by that force, no work is done. That means this is equal to 0. Okay. Therefore, delta K plus delta U equal to 0. Or you can say loss in the gravitational potential energy converting into kinetic energy. Okay. Right. I'm writing here initially potential energy. Initially potential energy equal to, I'm writing here minus because I'm taking this table as now reference level. That is the reference level. So for the part of the chain on the table, no potential energy. For a hanging one, since it is now below the reference level, potential energy is negative. And that is mass is m by L into L, mass of hanging part, G. H is now L by 2. I have taken center of mass. Right? In the last question I have discussed, if chain is uniform, we can take center of mass, means midpoint. Finally, potential energy will be minus m g L by 2 because this edge is coming to, sorry, this end of the chain is coming to edge of the table. So complete chain is now like this, okay? This is now final position of the chain like this, right? So here potential energy is lost. That lost is converting into kinetic energy. That means initial value is greater than final value. Then see what is loss. I am writing here initial value minus final value minus m g L square by 2L initial value minus final value minus m g L by 2. This loss converts into kinetic energy, half mv square. Then see what we get. Throughout mass gets cancelled, remaining is g. G into, this is a plus, right? G into L square minus L square, right? Half of cancelled by L, that is equal to V square. Okay. Then V value, square root of this, right? So like this, we can use a conservation of mechanical energy. Okay. Let us see next one. See what is given here. An open knife edge of mass m is dropped from a height h on a wooden floor. From a height h. If the blade penetrates a distance s into the wood, the average resistance offered by the wood to the blade is, right. So initially dropped, finally it comes to rest. First of all, see the given data. Dropping from a height h. Suppose this is now wooden floor. Okay. From a height h, we are dropping it. And this penetrates into the wooden floor by distance s. Okay. So what is the average resistance offered by the floor? Take it as F, which we have to calculate. See how we are starting the problem. Given we are dropping from a height h, finally comes to rest. So initially no kinetic energy, finally also no kinetic energy. Okay. That means delta K equal to 0. Then what we have to think? Since delta K is known, we can write work energy theorem. W net equal to delta K, right? See how many forces acting on the block or on the knife. One is gravitational force until it enters into wooden floor. After that, along with the gravitational force, now resistive force acts. Resistive force means it will be upwards, right? Velocity downwards, but the force is upwards. Resistive force. So I can write here by gravity work done plus y by resistive force work done totally equal to zero. Okay. So by gravity, it has traveled a distance how much? H plus S. So it is now mg into H plus S. Okay. Resistive force. Force upwards, but displacement is downwards. Between these two angles 180. So we have to take here minus. Okay. Minus, I can say plus F into S into cos 180. Okay. I hope you got it. Cos 180 because displacement downwards, but force is upwards. So from this F equal to it is mg into 1 plus h by s, right? So like this, we can use work energy theorem. Okay.